Hello and welcome back to e-sipnayan. For today's video, we are going to discuss how to graph an ellipse. But before we proceed, do not forget to hit like and subscribe so that you'll get notified once we upload new videos. At the end of this video, you should be able to graph an ellipse. To start off, we answer this question: how are we going to graph an ellipse? And to answer that, I present to you the graphing ellipse starter pack. So given a standard form, there will be some information that we are going to identify. The first one would be the orientation, then the center, and the values of A and B. We practiced last time how to identify the orientation. You already know how to identify the center. And of course, we also practiced how to identify A and B. In the given standard form, there are also some information that is necessary but is not directly or explicitly shown in the standard form. And those are the following: the value of C, which will be used to plot the foci. This is the formula. And also the value of LR, which would be B squared over A. So basically, we're always going to identify first orientation, center, A and B, and these are the things that we need to solve. So how now do we formally graph an ellipse? I present to you the steps that I will be using in this video. First and foremost, we identify the orientation, then the center, because just like a circle, the center is the first one to be plotted in an ellipse. Next would be the vertices. To plot the vertices, we need to know the value of A. Now, if it is a horizontal ellipse, plotting the vertices will be to the left and right of the center. If it is vertical, then it will be up or down. Similarly, in plotting the co-vertices, CV sub 1, CV sub 2, we use the value of B. And to plot the co-vertices of a horizontal ellipse, the movement would be up and down. For a vertical ellipse, the movement would be to the left and to the right. Then lastly, we need the value of C to plot the foci. So we have 2. And take note that the vertices and the foci are always aligned. Lastly, we need to get the value of LR using the formula B squared over A. And we need to be able to generate 4 endpoints of latus rectum labeled as LR sub 1 until LR sub 4. Then lastly, to draw the ellipse, the points that we are going to connect would be the vertices, co-vertices, and the latus rectum endpoint. Let me now discuss how are you going to plot the essential parts of an ellipse if it is a horizontal ellipse. So we start by plotting the center. So say for example, the center is plotted here at the origin. That will be labeled as HK. Next to be plotted after the center would be the vertices. And since this is a horizontal ellipse, in plotting the vertices, we are also going to move horizontally. That is to the left and to the right of the center. So to the left and to the right of the center, using A units, we are going to label now them as V sub 1 and V sub 2. Now, if you do not want to graph and you want to identify the coordinates of the vertices, then you can use this formula. Take note that the movement is horizontally. That's why we are adding and subtracting to H how many A units. And then we simply copy K because there's no movement vertically, just horizontally. That's why we manipulated the x-coordinate, in this case, H. Meanwhile, to plot the co-vertices, it will now be the opposite orientation, upward and downward. So the co-vertices will be B units above the center and below the center, B units as well. Again, if you do not want to graph the ellipse and you want to identify the coordinates already, then you can use this formula. Take note that this time, we are adding and subtracting to K, which is the y-coordinate, because we moved vertically as well. So if it is a movement above, that will be plus. If it is a movement below, that is subtraction. And what value are we going to use? Of course, the value of B, which is assigned to plotting the co-vertices. Next to be plotted would be the focus, and take note that the focus should always be aligned with the vertices, so the focus will also follow the orientation of the ellipse. So since this is horizontal, the movement will also be to the left and to the right of the center. Now, the foci are labeled as F sub 1 and F sub 2. And if you notice, it is aligned with the vertices. Take note as well that the foci should be in between the vertices or the major axis because the foci should be less than the vertices. Now, if you do not want again to graph, here is the formula you can use to identify the coordinates of the foci. Take note that we moved horizontally. That's why there is a manipulation here in terms of the x-coordinate. H was added and subtracted by C. Why C? Because C is the number of units assigned in plotting the foci. Lastly would be plotting the endpoints of the latus rectum. We just simply need the formula b squared over a. And since the endpoints of the latus rectum are 4, we need to know where the latus rectum should pass through, and that is here at f sub 1 and f sub 2. So since this is a horizontal ellipse in plotting the endpoints of the latus rectum, the movement will be up and down the focus or each focus. Now, if you do not want to graph yet, then you can use these formulas, 4 formulas, for you to be able to identify the endpoints of the latus rectum. So notice that from the center, there is both a vertical and horizontal movement in plotting the endpoints of the latus rectum. That's why we manipulated H and also K. Then after that, you need now to connect the vertices, co-vertices, and the endpoints of the latus rectum to construct the ellipse. Example number 1, we have x squared over 36 plus y squared over 9 equals 1. We first identify the orientation comparing the denominators. 36 is larger than 9 and 36 is related to x. Therefore, this should be a horizontal ellipse. Meanwhile, for the center, this should be at 0, 0. So we plot the center at the origin, labeled as 0, 0. We need to identify the value of a, and a is simply the square root of the larger denominator, which is 36. So the square root of 36 is 6, so the value of a is 6. To plot now the vertices, we use a units. And since this is a horizontal ellipse, the movement would be from the center to the left and to the right, 6 units. So 6 units to the right will give us 6, 0. And 6 units to the left will give us negative 6, 0. And those would be the endpoints of, or those should be rather, the coordinates of the vertices. Next to be plotted would be the co-vertices using the value of b. So b squared is 9, so the square root of 9 is 3. To plot the co-vertices of a horizontal ellipse, the movement would be up and down from the center. So moving 3 units above, that will give us a CV sub 1 or 0, 3. And below will give us 0, negative 3. After that, of course, we need C. And C is approximately 5.2. Again, just to recall, how do we solve for C? The formula is the square root of a squared minus b squared. Moving on to plot the foci, we follow the orientation of the ellipse, which is horizontal. So we plot the foci to the left and to the right. How many units? 5.2 units. So since this is a decimal, it will just be a mere approximation. So from the center, 5.2 units to the right, the coordinates of the first focus would be 5.20. Meanwhile, if we move 5.2 units to the left, the coordinates of the second focus would be negative 5.20. And lastly, we need to plot the endpoints of the latus rectum. So we need to substitute it to the formula b squared over a. When substituted, the value is 1.5. So we are now going to move 1.5 units above and below the foci. So for the first 2 endpoints of the latus rectum, let's move 1.5 units above here at this point. And the endpoints would be 5.2, 1.5. For the other endpoint, that would be negative 5.2, 1.5. Then if we move below this point, that would be 5.2, negative 1.5. And lastly, if we move below this focus, that would be negative 5.2, negative 1.5. Then lastly, connect the vertices, co-vertices, and the endpoints of the latus rectum, so that we'll be able to construct an ellipse. And this is now the graph of x squared over 36 plus y squared over 9 equals 1. Let's now have an example of a vertical ellipse, and we start again with a center. Say for example, it will be plotted here. Then next would be the vertices, which will be plotted above and below the center because the orientation is vertical. Notice that we are manipulating here the value of k, wherein we are adding a units. Moving above will be related to addition. Moving below will be subtraction. And then since we are plotting the vertices, it is best that we use letter A as the number of units in moving up and down. Meanwhile, in plotting the co-vertices, it will be to the left and to the right from the center. And notice here that this time we are manipulating the value of h. We are adding b and subtracting b. Subtract if we go to the left of the center, add if we go to the right. And why b units? Because b units is the measurement from the center to a co-vertex. Moving on, in plotting the foci, it will be the same direction as the orientation and the vertices. So since a while ago in plotting the vertices, we moved vertically, that will be the same direction for the foci. And notice that we are again manipulating the value of k, but this time we are adding and subtracting the value of c because the distance from the center to a focus is c. Lastly will be the endpoints of the latus rectum, and if you notice, you can use these four formulas for you to be able to solve the latus rectum endpoints, especially when we have decimals later on. But if all of the given will be whole numbers, then there will be no problem. You just simply need to count, and you can refer to this formula to counter check your answer. So if you moved above the center, definitely the h value will be added b squared over a. If you move below, just like the latus rectum endpoints here, you are going to subtract b squared over a. Then if you move to the right from any movement vertically, you're going to add, and the value will be c. Meanwhile, if you move to the left, just like these points here, you're going to subtract c. Then after that, again, to draw the ellipse, what you're going to connect would be the points, vertices, co-vertices, and the four endpoints of latus rectum. Let's now have this example, and this is a vertical ellipse. To start off, we need the center, and the center is hk, which will be negative 1, 2, which will be plotted on the second quadrant here. Next, we need to plot the vertices, and we need the value of a, which is 3. This was obtained by getting the square root of the larger denominator, which is 9. So the movement will be 3 units up and down. So we count 3 units above, 1, 2, 3. That will be the first vertex plotted at negative 1, 5. Then count 3 units below the center. That will be the second vertex at negative 1, negative 1. Next, we need the value of b to plot the co-vertices. And that will be the square root of the lower number, which is 4. So square root of 4 is 2. Then from the center, we count 2 units to the right, 1, 2. The first co-vertex will be plotted here at 1, 2. Then let's also count 2 units to the right from the left from the center, 1, 2. This will be the second co-vertex plotted at negative 3, 2. Then to plot the foci, we need to get the value of c, which is just the square root of the differences of the square of a and b. So that will be approximately 2.2. It's best if you round it off to 1 decimal place so that you'll not be confused with a lot of decimal. So the movement from the center up and down will be 2.2 units. So this will just be merely approximation. So from the center, 2.2 will be somewhere here, and that will be plotted at negative 1, 4.2. So what happened here? It will be aligned with the vertices and the center. That's why the x values will be the same, negative 1. And then for the y coordinate or the y value, we added or we moved above 2.2 units to k, which is 2. That's why that is 2.2 plus 2. So the value will become 4.2. Meanwhile, if we move 2.2 units below, 2.2 is somewhere there. The value of the other focus would be negative 1, negative 0.2. Again, the x value will be the same with the other focus and the vertices and the value of h because they are aligned vertically. Meanwhile, for the y value, since we moved 2.2 units below, we're going to subtract 2.2 to k. So that is 2 minus 2.2. That will be negative 0.2. After that, we now plot the endpoints of the latus rectum. That will be from the focus to the left and to the right. So that will be b squared over a units, which will be approximately 1.3 units. So again, since this is a decimal value, we are just going to approximate. From the focus, we count 1.3 units to the right and to the left. So if we count 1.3, so 1.3 somewhere here, we are going to have a value 0.34.2. So notice that the focus and the latus rectum will have the same x-coordinate 4.2 because they are aligned horizontally. The only movement or the only value that will change will be the x because there's a movement horizontally. So what happened here? Starting from -1, we counted 1.3 units to the right. That's why that will be -1 plus 1.3, which is 0.3. Meanwhile, if we moved 1.3 units to the left, the endpoints of the latus rectum will be -2.3, 4.2. Again, the y-coordinates, let me highlight that one, of the latus rectum, the focus, will be the same. What is changing only would be their x-coordinate because the movement is horizontal. So starting from -1, we counted 1.3 units to the left, which is the same as subtracting 1.3 to its original coordinates position, -1. So -1 minus 1.3 is -2.3. That's why we got this coordinates. So meanwhile, if we start now from this focus, we still move 1.3 units to the right, and that will have coordinates 0.3, -0.2. Notice that it will have the same x value as the aligned, this one, as the aligned latus rectum above it, but of course it will have a different y value, which is -0.2. So starting from this focus, -1, we moved 1.3 units to the right. That's why that is also addition, -1 plus 0.3. Meanwhile, they have the same y coordinate, which is -0.2 because they are aligned horizontally. Meanwhile, if we move the 1.3 units to the left, that will have coordinates -2.3 and -0.2. So notice that it will also have the same y coordinate because they are aligned horizontally. But meanwhile, this one, the x value aligned to the LR above will be the same. Or this is the same as subtracting 1.3 to the value of x of focus 2, which is -1. So -1 minus 1.3 is -1.3. And after that, you are now going to connect the vertices, co-vertices, and the endpoints of the latus rectum so that you will be able to construct an ellipse. And this is the procedure of how you're going to graph a vertical ellipse. So that will be the end of this video. I hope that at this point you were able to identify the steps in graphing an ellipse. This is all for this video. See you on the next one. Goodbye!